Every precision motor shaft begins with carefully selected steel stock. The carbon steel bar is guided into the automatic sawing station. Rollers position the material, while clamps hold it firmly for cutting. The saw advances at a controlled rate, producing a clean and square end face. Each cycle creates another blank with a consistent starting length. From this simple cut, the geometry of the future shaft begins. The next stage joins the metals into one engineered component. The short section is made from 300 for stainless steel. The longer body is carbon steel. Both parts are aligned precisely along a common center line. Rotation and axial pressure generate heat directly at the interface. The softened surfaces forge together, forming a strong continuous joint. The welded blank is now ready for precision machining. At the CNC turning line, the welded blank is secured and supported. Program tools begin shaping the main outside diameters. Successive passes create shoulders, steps, and smooth transitions. Coolant controls heat and carries metal chips away from the cutting zone. Every movement is governed by the machining program. This repeatability keeps dimensions consistent from one shaft to the next. The finished profile now clearly reveals the form of the motor shaft. The turn shafts move to the keyway milling station. A dedicated fixture locates and clamps several pieces at once. The cutter aligns with the exact position defined by the design. With controlled depth and feed, the straight keyway takes shape. This feature will transmit torque between the shaft and the rotating assembly. Uniform width, depth, and alignment are essential for a reliable fit. Once the slots are complete, the shafts proceed to grinding. Turning creates the profile, grinding creates the final precision. Each shaft is loaded and supported inside the automated grinding line. The abrasive removes only a very thin layer of material. Diameter, roundness, and surface finish are refined at the same time. A continuous flow of coolant controls temperature at the contact zone. This protects the dimensions already established during turning. As the shaft rotates, the wheel advances with a steady, measured feed. Material is removed in microns rather than heavy cuts. Earlier machining marks gradually disappear from the surface. The finished journal becomes smoother, brighter, and more accurate. Different shaft sections are ground according to their own tolerance requirements. Automated handling transfers each workpiece through the required positions. Consistent grinding supports reliable bearing fits and stable motor operation. Only fully finished shafts move forward to the next stage. A selected section of the shaft now receives a nail pattern. Hardened rollers press against the rotating surface under controlled force. The pattern forms evenly around the full circumference without removing material. This textured surface provides a secure mechanical interface during assembly. The final stage is inspection, where every critical feature is verified. Each shaft enters the measuring station from a control reference position. The fixture secures the part while probes contact the required sections. Sensors compare the measured value with the program tolerance limits. Results are recorded automatically, allowing deviations to be identified immediately. A conforming result confirms that the shaft meets the required dimensional standard. From sewing to final inspection, precision has been built into every step.
Yinjia pump since 1990.